please welcome CTO, Amazon.com, Dr. Werner Vogels.
Good morning, San Francisco. How are you? Come on, get some, bring some life. Yeah. Thank you all for coming out here today. As you can see, it's just not, our business is growing so much that, one room is no longer enough. So I hope that you all can enjoy today with being here, and we can get you all great educational content. Because that's really what these days are about. Yesterday as well as today, the whole principle is that this is not a sales conference. This is not us selling you things. It is all about educating you how maybe your peers are using AWS. And if you go to many of the breakout sessions today, you'll find that it's mostly the person next to you that will actually be telling you about how they're using AWS and how you can learn from that. So, well over 7,500 people are present here today. Thank you for all coming out here and listening to us. We have well over 50 breakout sessions for you. And of course, many of our partners are here as well to talk to you about sort of the offerings that they have on our platform, which is really important for many of you. So I want to start off with giving you just a little bit of a quick update on where we are in the AWS business, and then sort of dive into the more technical content after that. So we're, at this moment, a $14 billion run rate company, based on the 12 months trading in Q4 of last year. And so still showing 47% growth. That is incredible. Yeah, and if you look actually at all the billion-dollar enterprise companies that are out there, AWS is absolutely the fastest growing. And if you see that many of these old companies that are actually on this slide, like Microsoft and Oracle, they're actually retreating. Yeah, they're sort of contracting their growth instead of sort of expanding it like AWS is doing. And so with that, we're very fortunate to have millions of customers, millions of businesses running on our platform. And so it's obvious that many of the startups who have the opportunity to build new products from scratch in a greenfield are building this on the cloud. And if you look at these names on this slide, this is incredible. These are young businesses, but in essence, they have become household names just in a few years. Yeah, if you look at Airbnb or Pinterest or any of those, all of us know them as being sort of the default applications or the default services that we use today instead of these big enterprises that used to run this space. And the fun actually is that Twilio is still on this slide. Yeah, and I think Twilio is absolutely the biggest success story of the past year. Going public very successfully. And if you listen to their story, you will hear that the way they became successful was by purely focusing on delivering sort of the telecom functionality that they had in mind and making use of every possible AWS service out there. When we launched Lambda, they were one of the first ones to actually jump on board and knowing exactly what they could do with that functionality to process some of the audio content that they have. So if you listen to Jeff Lawson, he will tell you that their success has been really tied into AWS. By us delivering this breadth and depth of services that we do, helps them become successful. And the same goes for enterprises. There isn't a possible vertical today that is not making use of AWS. Yeah, and whether that is healthcare, with Philips building their new healthcare suite on top of this, whether it's oil and gas, with Shell and BP, whether it's news organizations like The Guardian or News Corp or Dow Jones, every possible vertical out there is actually making use of AWS today. And the same goes for many of the public sector companies out there, or whether it's 2,300 government organizations or universities out there, educational institutions, 7,000 of them around the world making use of AWS, and well over 22,000 non-profit organizations are making use of AWS to serve their citizens or their customers better. Important for many of you is the consulting partners that are actually helping you be successful on our platform. And in here, you see both sections. And one section is still the traditional, the global SIs, the global system integrators, like Accenture and like Capgemini and Wipro and Infosys, that have been for a very long time successful with our customers. But also these new born in the cloud system integrators, like SecondWatch, like CloudReach, like Minjar, like Nordic Cloud, that all have adopted a cloud-native model in their own operations, giving you a very agile approach to system integration, helping you get to the market really quickly. And so both of them are actually really successful on our platform. Now, you couldn't do this probably without the ISVs that are out there. So many of the software vendors, I think actually possibly every software vendor today makes sure that their software runs really well on AWS, because that's where you are. And you are more or less attracting them to the platform because ISVs know that they need to be on AWS to serve their customers better. And one of the important mechanisms for you to consume their software is through the AWS Marketplace. It has well over 135,000 active customers on there, 3,800 software listings, and many, well over 1,000 participating ISVs that actually have their listings on the platform. And each month, well over 370 million hours of EC2 are being consumed by Amazon Marketplace products. And so you find in the marketplace both traditional software, where they've created sort of AMIs that you can run yourself, and actually we're also giving the ability to actually consume SaaS applications through this model. You can have a subscription to a SaaS product. Now, many of you have been sort of making these longer-term contracts with these SaaS companies and found it very challenging to actually do this through the marketplace. So today we're launching a new mechanism for you called SaaS contracts that allow you to, with these SaaS companies, actually have 1-, 2-, or 3-year contracts in a very easy manner to actually engage with your customers, to engage with their customers. And so it's easy for you to upgrade these contracts or expand them anytime that you want. And it's easy for ISV to actually integrate with this and bring new contracts into the marketplace through an API. And so SaaS is becoming a critical approach for many customers to start consuming new software, because it's such native to cloud. Many of you will be going through sort of, if you still have on-premise software, through a sort of traditional cycle of licensing and having software on-premise. And you may go through this, what I would call IT live event. So there's the license for this on-premise software is running out. So what are you going to do? Are you going to buy more software and run it on-premise? Or are you going to go with a software as a service solution? And we see a tremendous rise in this. And we see also tremendous investment from ISVs to make their product available in software as a service. And probably one of the best examples and one of the earliest players of really moving their traditional software environment into a software as a service model at a really technical level is Splunk. So I'd like to invite Doug Merritt, the CEO of Splunk, on stage to have him talk about sort of how they went from enterprise software into a software as a service solution. Doug.
Thank you, Werner. Thank you, Werner. Good morning, everybody. I'm Doug Merritt, the CEO of Splunk, and I am fired up to be here today to share our journey to the cloud with you, as well as talk about our next big move on AWS Marketplace. We've been a strategic partner with Amazon for almost 5 years now, and we've watched together as folks like you have gotten the combined benefits of the incredible scale-out and rich services that AWS provides, combined with the end-to-end visibility that Splunk can provide to our customers. We're going to take it to the next level with this release of Marketplace, making it easier to buy and run Splunk Cloud for all of you. Time is our critical enemy, and Marketplace is revolutionizing and will revolutionize how all of you buy enterprise software. For those of you that may not know Splunk, and hopefully most do, let me give you a few highlights. We were founded with a pretty revolutionary notion. How do we make machine data accessible, usable, and valuable for everyone? Machine data, often overlooked by most folks. It's big and growing. And through tools like Splunk, you can drive what we call operational intelligence from this machine data. Let me give you a few examples. Yelp uses Splunk to ensure that they have end-to-end visibility across their complex web landscape and that their new delivery service gets orders on time to their customers with quality. Coca-Cola uses machine data and operational intelligence to survey and keep track of the changing tastes of their customers and to ensure marketing dollars are matched to those changing tastes. Someone like AAA makes sure that roadside in-need folks can get quickly connected to an operator, pretty timely thing, and then does an even crazier thing and ensures perimeter security of their physical presence as well as network security. So how did this Splunk journey start? We were founded 14 years ago with back then a pretty radical idea. Let's have an enterprise on-prem solution that's free at first. You can find it from any website, download it, and immediately use it in seconds. But 4 years ago, we delivered our first Splunk instance in the cloud with AWS. Shortly after that, we released our Splunk app for AWS. Anyone in the audience get a chance to use it? I think many of you probably do. It's one of our most popular apps in Splunk Base, which is our app store. It provides capabilities for companies like Autodesk to get end-to-end visibility across a really robust and rich set of services that we all have available to us in AWS, so they can save hundreds of thousands of dollars in capital costs, time, and labor. After that, we moved to an Omni solution, making sure that Splunk was available in every AWS global region through one centralized console. Like AWS, customer obsession is a foundation for Splunk. It's literally our #1 corporate priority and objective, which makes partnering with someone like AWS even that much more natural and easy. Also makes it easy to listen to you, listen to our customers as you're telling us. You already have contracts with AWS through Marketplace. You already have payment terms established. You might have buying vehicles, and we needed to make the buying process easier for you to find Splunk. You talked, we listened, and the AWS Marketplace team made it incredibly easy for us to actually comply. So today, we're announcing a fundamentally new way to find, buy, and use Splunk in the cloud. We're taking advantage of that new SaaS contract API that Werner was talking about. It enables a brand new go-to-market approach that delivers a seamless digital experience with significant enhancements in ease of procurement and gives all of you continued visibility across your cloud infrastructure plus hybrid and on-prem, which is one of the core aspects of Splunk. So why am I so fired up about this? Why am I so excited? I have been in situations I'm sure you guys face over and over in my career where I've got teams of developers, they're frothing at the bit, they're ready to go. And with AWS, they actually have their infrastructure. And one of the holdups can often be waiting for that procurement cycle to complete. We're burning time. We don't have time if we want to be agile and quick, like we all need to be every single day. So it's now significantly easier to find. As Werner talked about, 130,000 of you guys are using AWS Marketplace, important for easy to find. It's easy to buy. And as you buy, it actually can go across your existing contracts with AWS. Of course, we're going to offer standard term-based pricing. We rolled out 1 year at the announcement today. You'll see 2 and 3 year coming very, very shortly. And the longer the contract, the cheaper the price. Standard term-based pricing. And as Werner talked about earlier, there are so many partners using AWS Marketplace right now. Partners are a heart of what we do at Splunk. They're responsible for the majority of the 1,300 applications that are part of our app store called Splunk Base. So with this announcement, it's not only easier for our customers to quickly get what they need, but it helps drive time and business expansion for our partners as well. We fundamentally believe that the AWS Marketplace team is changing forever the way that we procure, deploy, and drive innovation in this cloud world. If you're customer obsessed, then helping you drive innovation and speed, velocity, and time is key has got to be the heart of what we do. I urge you to go to splunk.com/AWS Marketplace. Don't be left behind. Get your contract and test it out for yourselves. Thank you very much.
Thank you, Doug.
Thank you, Werner.
Great.
Thank you.
As Doug said, there's a few principles behind the things that we do in AWS. One of them is, of course, always we want to make it simpler for you. Yeah, I mean, so that you can really focus on building the products and the businesses that you want to. And so making things simpler through procuring software through the marketplace is one thing. And I forgot to mention that earlier on, and Doug actually hinted at that. One of the making it easier is that you get one bill. That you get all these companies that you acquire the software through the marketplace appear on your monthly bill at the end of the month. Yeah, so that makes it much easier for you to actually run and consume software on top of AWS. Now, if I look back over the past years, we've all been sort of talking about how cloud has become the new normal, where it's become the default environment for you to build new products onto, or to actually start migrating your existing infrastructure into. It's become the new norm. This is normal. This is what we do. This is the default environment. And when we dove into that, really, why was that the case? Why did it get so quickly traction? Was that because we freed you from sort of the constraints of traditional hardware and traditional hardware procurement. The ability to actually move fast. The ability also to no longer be shackled by sort of 5-year contracts that you had to do to really get the cost down of the contracts that you had, and often overpaying for them. And so this freedom sort of has given you sort of tremendous powers. Yeah, and when I talk to AWS customers, they often say that they feel like James Bond, where AWS is Q. Yeah? We're giving you all these fancy tools that you could do things with that you never knew you could do, or where you always thought that you had to do them yourself, where you had to build these tools yourself, and we will give them you now. And so these superpowers that AWS gives you allow you to move fast, allow you to get your products out quickly, and most importantly, purely focus on what's your unique business, instead of having to worry about infrastructure or scaling or reliability. All of these kind of things are taken care of for you if you use some of the managed services, for example, that AWS offers you. So let's take a look at some of these superpowers that you get. Of course, the first one, and a really important one, is that of supersonic speed. With AWS, you can move so much faster. And it's not just faster because you can get access to 100 or 1,000 or 10,000 instances just in minutes' notice, instead of the months or 6 months' time that it would take you to actually roll this out yourself. The ability to move really fast is also triggered by having a very broad and deep ecosystem of services available for you, so that you can really focus on, that you no longer have to focus on building your own search service, that you don't have to install Solar and Lucene and sort of try to make those scale, or whether you don't have to do your own caches, whether we can actually manage those for you. All these different components out there make that AWS is really powerful and gives you the powers to move fast. Really focus on the products that you want to build, instead of focusing on sort of managing all these different services that do not give you a competitive differentiation. And so well over 90 services is what we have today for you, and we continue to roll out new features and new services at what I like to believe is really a neck-breaking speed, mostly by feedback from you. Last year, we launched well over 1,000 major new features and services for you. And they are in such a broad domain, whether it's in IoT, or whether it's in mobile development, or whether it's around development. If you just take a look at sort of the services that we have available for you to actually help you do development, there's a very broad set of services available for you. But actually, at this point of trying to make it easier for you to develop on our platform, I think we can still make some progress there. I think there's still so many pieces in development that require you to use many different tools. And if you're like me, you have this muscle memory. So I can switch between the IDE, or VI, or Emacs, and so my compiler, and I can switch over to my console, and I can switch over to Jira, and I can switch over only by using sort of keystrokes and things like that, thinking that I'm extremely efficient in all of this. Mostly because this is how I've been doing things forever. But in reality, I'm just using a whole set of tools that are not really integrated very well together. And if I think about building new products or new projects, there's all these things that you have to do up front to pick the right tools, to develop the pipeline, things like that. So there's a setup phase with this, and especially if you do continuous development. There's a setup phase with this where you need to get all your tools ready. Then there is this sort of phase where you go through in your project where you get team members in and you have to manage security and role-based access and things like that. And then you have to go do continuous integration and development. That's, again, building the pipeline, pushing it through, often using 5 or 6 different tools in that whole pipeline. It is too hard, in my eyes, especially if we want to accelerate the development of digital products. We really need to make development a lot simpler. And with that, I'm announcing today a new product from AWS. It's called AWS CodeStar that helps you to really simplify development. It allows you to very quickly develop, build, and deploy applications on AWS. It starts with a whole new integrated environment where you can basically pick what kind of project that you have, the targets that you have in that particular case. You can build a Lambda application, you can build a Beanstalk application or run it on EC2. And you can set up security in a matter of minutes, really finding role-based access for how your team members can access these services. And you can integrate it with a continuous integration development. So that's all very abstract, of course, if I say it like that. But let's take a look at how this looks like. You start your project with picking a template. There's over 20 templates where we start off with, different programming languages, different target environments, and even AWS Lambda is a target environment for you there. So next step is you set up your team access, you build out the roles that different people in your team have, what access do they have, what kind of controls do you want to have in place, and then you configure your continuous integration pipeline for you, and all the tools underneath that get configured for you. Then you connect your IDE to it, and you start building your code. And then we give you this monitoring and management environment with that, where you can actually monitor and manage the continuous integration environment that you've built. So making it really easy for you to actually go from the beginning of your development process to immediately starting integration and development. The cool thing of all this is actually that Lambda is one of the targets there, so you can immediately set up continuous integration and deployment towards Lambda as one of your target environments to use there. So that is development, trying to make development much simpler and much easier for you, taking away much of this heavy lifting that has always been associated with development. Now, in all of this beautiful, let's say, overview of all these services that we have, there's still this little box underneath there that seems to sort of flow away from the rest of the environment, but that's still really much core to all of that we do. The AWS core services: compute, storage, databases, networking. And this is a small box in the overall setup. But if you look what sits inside that box, it's incredibly broad. There is every possible type of compute that you can do, different types of databases, all the different ways that you can actually secure your environment, all the different networking capabilities that we give you. And so it may be a small box, but it has incredible depth. And it's not just that it has this, that is so broad and so deep, because within all of these, for example, in the T2 environment, you have many different sort of size models that you can use. So you have these double dimensions. You have and the number of compute instances that you can choose from, and sort of the sizing that you can pick. And in my eyes, there's always a third dimension as well. So let's take a look deeper at compute, actually. So these are the current sort of instance families that we have. And for me, one of the most important things here is the numbering behind it. If you, at one moment, would have to buy hardware yourself, you're stuck with it. the cool thing of AWS is that we continuously refresh our hardware environment, allowing you access to the latest processors. For example, Skylake on the C5s is something that you have in your hands already. If you would have to actually go through this procurement cycle yourself, that would be probably cost prohibitive for you to move this fast and get access to the newest hardware as fast as that we, AWS, can give you. Yeah, so the real sort of the powerhouses in this, the M4s and the C5s, are already on the 4th and 5th generation of those. Yeah, and those are sort of the generic compute environments. Yeah, and then we have the dedicated ones for dense storage and for high I/O and high memory usage, all the way up to the X1s, yeah, where you can actually run SAP HANA in memory. And the specialized instances with GPUs, whether it's G2 that really focuses on doing graphic processing, or the P2s, which have these general-purpose GPUs that have larger memories on the GPU boards that make it really well suitable for doing, for example, deep learning on these platforms. Yeah, and then at one end, there's Lightsail, which makes, again, all of this consuming of compute environments much easier for you. And on the other hand, there's the really dedicated environment of the F1s. So F1s are field programmable gate arrays. Yeah? And that is something you can use to build very fast acceleration of your software. Yeah, so today, the F1s are available for all of you to use. Yeah, they're generally available today. So if you look at what F1s actually can do for you, is you can actually develop, again, very simply, software on your desktop, packages as an FBA image, and bring it over to an F1 instance, and then get tremendous acceleration of the software that you have built. Really, hardware acceleration of your software. The cool thing is that others are actually building these FPGA images as well, and making them available for you on the marketplace. Yeah, so check those out. For example, in video encoding. Yeah, if you look at the sort of the different use cases in all of this, probably the most consumer-oriented one of as a developer, I mean, is that of real-time video processing. Yeah, there's images available for you that will speed up your real-time video processing by 30x by running it on an F1 instance. So with that, really trying to satisfy all your needs, and where you have tremendous choice. You no longer need to be afraid, by the way, to make mistakes. If you make a mistake in the past, you will be stuck with it forever because you bought this piece of hardware and you would have to live with it. Just because you thought it was CPU-bound, but it turned out to be I/O-bound, you're still stuck with it. Today, if you make a mistake, you pick the C5 as your instance, but it turns out that you're way more disk-bound. Yeah? You might pick a different, you might pick one of the other instances. You might pick an I2. So all of these choices, the breadth and depth of this is what makes AWS so powerful. And our goal is always, and this is another superpower, is to make infrastructure go away, to make infrastructure invisible so that you can actually really focus on what you want to build as an application builder. And probably there is no other area where this is more important than in development, in picking your architecture. Yeah, and so we've always kept you away from sort of the constraints that were in there determined by sort of this fixed infrastructure. And there's two sort of, I think, modern development patterns that really have risen because of cloud and because of a few other technologies around cloud that help you build modern architectures. Yeah, on one hand, microservices, and the other hand, serverless architectures. So let's take a deeper look at that. So the rise of microservices really has come out of this world where when we were building monolithic software or larger monolithic pieces, we started to realize that in those monolithic pieces, there were actually components that had very different scaling and reliability and security requirements. Now, imagine you have in there, for example, a component that deals with credential management of your customers, and there's also a component in there that has, for example, the address book of your customers. It's all working on customer data in this system. It means actually that if you run in this monolithic environment, that your address book service, your address book part there, actually also has access to the credential store. Yeah, or that if you need to scale this up, you need to scale it up at the scalability requirements of sometimes the smallest component in there, which in this case is the credential service, which will probably be hit on every page that your application services. Yeah? While the address book service that needs to scale down suddenly, just like the credential service, actually only needs to be accessed whenever you do a checkout of a product. Yeah? And so our realization that we need to cut up things, decompose them into smaller building blocks, is sort of crucial to the whole world of microservices. Yeah? And so I think microservices really have gained interest by the fact that we now have container technology available for us to actually get us there. And this is a slide actually from one of my presentations when I talk about Amazon.com, the retailer, about the sort of the architectural phases that we've gone through there. And I wish we had had containers available when we moved to microservices. So Amazon really was, in the end of the 90s, early 2000s, a true monolithic application. We went as one of the first to a service orientation model. And actually, when we did that, we had made mistakes. Yeah, so we've done some pieces were functional decomposed, but others were just driven around sort of the large data sets that we had. So we put everything in a customer master service that operated on the customer data. And it's really the example that I just gave. The login service set in that piece, as well as the address book service, and all needed to scale in the same manner, all got the same security protections. Moving to microservices, for us doing then a functional decomposition on that customer service, really allowed us to become way more secure because the attack surface really decreases, while having much more control over your scalability and your reliability. Containers are not easy, though, today. And I like to believe that some of the things that we see, if you take off-the-shelf sort of container management software or some of the open source products that are out there, it almost brings you back to the world of pre-cloud. You have to manage all these pieces. Yeah, and you have to actually give up on security in many of these cases. Yeah, and so you come back into actually managing these containers over complete clusters of infrastructure. Everything is back almost 10 years ago, if you actually move to sort of this container environment, which was for us the driver to build ECS. Yeah, the Amazon EC2 container service, in my eyes, is the absolute best way to run your container environments in production. And of course, we do all these things like container management. We give you a container registry where you can store your images. We help you automatically with doing multi-AZ deployments, different types of scheduling. But most importantly, is the deep integration with all the AWS services out there. And whether that is sort of EBS and ELB and CloudWatch, or whether it's IAM, all of those is really important for you. Yeah, and so this whole platform strength of ECS is beyond just container management and container scheduling. It's really the deep integration with all the other services that we have. You want to route traffic based on some naming prefix to your individual tasks, you can do that using ALB. You want to get access to the logs of each and every one of these tasks in one particular place, for one task in one place, you use CloudWatch logs. Do you want to do auto-scaling on your individual tasks? You can do that using ECS. And most importantly, you can set individual access control rules on each of the different tasks. So your credential service task only gets access to the credential store, and no other component gets access to that. And your checkout component or your address book component only gets access to DynamoDB, where the information of the customer's address books lives. Yeah, and so that way you can get very fine-grained control over exactly what these components can access. And it's extremely important for you. Yeah, and we have, fortunate, it powers many, many of our customers today. Yesterday, the guys at Mapbox actually put out a great blog post that you should read, although I thought that Eric really took its time and actually built a sort of really catchy title on that. Go lead that. I think the title was, Mapbox moved to ECS, and you won't believe what happened. Well, what happened is that they cut their cost in half. purely by using ECS and having a much more efficient way of mapping their compute units onto, say, the cluster environments. That's one thing. The other thing is that they do a lot of batch processing using ECS. They do that on spot instances, which cuts their costs down tremendously. And so for them, this really helped them to become a much more efficient organization. And remember, these guys process a lot of data. They process 100 million miles of sensor data each day. They have well over 5,000 apps that run on top of this, 200 million users, and they serve 1.3 billion requests each day. And for them to actually drive the cost of their infrastructure in half is a significant important thing for their business. And so there's probably no greater sort of customer of ECS that has been very vocal about how to be using ECS than Nextdoor. The well-known, let's say, local social network that helps you sort of communicate with people that really live physically close. And I'm happy that the co-founder and chief architect of Nextdoor, Prakash Janaki-Raman, actually is available today to tell you about how they are using ECS. Prakash.
Thanks, Mike. Appreciate it. Thank you, everybody. My name is Prakash. I am one of the co-founders of Nextdoor, the private social network for neighborhoods. And I'm excited to tell you a little bit more today about our story with ECS. But first, let's take a little look back almost 7 years ago when we started the company. We were fascinated by what we were seeing in the landscape of social media. People were using Facebook to connect with friends and family all over the globe, and Twitter to connect with people with whom they shared common interests, and of course, LinkedIn for our professional network. But we felt like there was something very important missing. What about that part of our lives that's closest to home, where we live, where our children play, our neighborhoods? In spite of having hundreds of Facebook friends and thousands of Twitter followers, I only knew 2 of my neighbors in my San Francisco neighborhood. And it turns out we weren't alone. A Pew Research Institute study showed that 29% of Americans knew only a few of their neighbors, while 28% of Americans didn't know a single neighbor by name. And this was the inspiration for us to create Nextdoor, to bring back a sense of community to the neighborhood, which before technology was really the original social network. Every day, millions of neighbors across the country are using Nextdoor to find a handyman or an electrician, to reunite with a lost pet, or even more critical things like reporting a rash of break-ins or banding together during a time of natural disaster. And it's not just for neighbors. Neighbors can now listen in on communications from their local police department and fire department. They can connect with local businesses, and they can even hear from local news agencies. And Nextdoor is growing fast. In our first year, we ran a private beta that yielded us 176 neighborhoods across the country. And I'm really proud of the team because today we are launching 100 neighborhoods a day. 135,000 neighborhoods across the country are using Nextdoor. That's 70% of the neighborhoods in the US. And each one of those neighborhoods was started by one motivated member. And so let's talk a little bit about what's powering our growth. And now we've been customers with AWS since day one. And today we use almost 30 different AWS services to run our business. I'm going to tell you the story of how we reduced our build and deployment times by nearly 10x through our use of containers and the EC2 container service. Now, like a lot of companies, we started out doing weekly releases. We had a release engineer who would cut a release branch every week, would integrate all of the changes, stage them in a staging environment, and we would verify them, and then push to production. But as the team started to grow, this became hugely unwieldy, and it was really difficult to manage, and we knew we needed to move faster. We wanted to break down those releases into more incremental steps and incremental components that we could deliver and isolate the impact of those changes. And we wanted to democratize and automate the process so that any developer could push their changes when they were ready. And so this led us towards continuous deployment. And luckily, we had made some prior investments in this area, in particular, a zero downtime deployment mechanism that was inspired by a talk that we heard from Netflix a few years ago at AWS reInvent. And the idea behind this system, the red-black deployment system, was pretty simple. Rather than updating software in place on running instances, every time we would do a code push, we'd launch new EC2 instances. We'd configure them, install our software, and once they were ready to serve, we could transition traffic over through ELB. And once everything was confirmed to be good, we terminate the old instances. And we were really happy with this system. It was stable, it was easy to do rollbacks, but it had one fatal flaw insofar as continuous deployment was concerned. It was too slow. It took us almost 25 minutes every time we had to build a package because we were using the Debian packaging system to contain all of our system dependencies and Python package dependencies, and deploying ended up taking another 30 minutes, booting instances, configuring them with Puppet, and installing our software packages. We knew we had to move faster to support continuous deployment. And so that's when containers come in, and Docker. Using Docker allowed us to use a much simpler expression of our build, using simple Docker files instead of the convoluted and Byzantine Debian packaging system. Packaging things up as a container meant that rather than using a package manager to actually install our application, we had a completely sandboxed environment, a full runtime environment that we could just drop onto a host. And lastly, we got huge speed increases by using Docker layer caching. By doing that, we only had to rebuild the parts of the application that changed. So by layering the system dependencies, the package dependencies, and then our source code, in most cases, we were only changing source code. So that dropped our build times from 25 minutes on average down to 2 to 3 minutes. And then we looked for a container management solution. And as Werner was talking about, we didn't want to run it. That was a lot of work. And so leaving all of that up to Amazon to manage the control plane was hugely attractive to us. And through native integrations with things like ELB and IAM, we could continue to use our prior investments in the red-black deployment system nearly unaltered. And lastly, because AWS was rapidly innovating the platform with things like ALBs, event streams, and CloudWatch events, we knew that they would move fast and continue to support us as we grew. So an updated look at our architecture, we still have Route 53 and ELBs that are routing traffic into our front-end web services. But those web services now run as tasks, packed into containers and packed into the ECS clusters. No more booting of instances, no more Puppet configuration, no more dependency installs. We dropped our deployment times from 30 minutes on average to 5 to 7 minutes. And we have 40-plus back-end services running on ECS today. Overall, we saw a nearly 10x improvement in our build and deployment times. And any of our 60 developers now can push a button and trigger a build. We've gone from releasing just a few times a week to dozens of times a day. And we get features out faster to our users, bug fixes out faster, and we've democratized development. At Nextdoor, we believe the sense of belonging and community is a basic human need. It's one that people all across the world share. And we're excited to bring Nextdoor to neighborhoods across the globe with AWS as our partner. Thank you.
Thank you, Prakash.
All right.
Amazing. Something that Prakash said is extremely important, I think, if you think about modern agile development. Yeah? The ability to deploy dozens of times a day means that you're going to automate everything. You're no longer going to make this a manual process. And the moment that you start automating, you're probably going to remove much of the vulnerabilities when it comes to human interaction. So the more you automate, the higher the likelihood is that you are going to have a secure, reliable deployment. Also, if your code changes are much smaller, it's much easier to actually do sort of reviews on it, whether it's any security violations or whether there are any reliability vulnerabilities potentially in there. If you have to review 15,000 lines of code and do that deployment once or twice a week, that's going to be a nightmare. Really moving faster, having small targeted deployments, dozens of times a day, maybe hundreds of times a day even, makes your overall system way more reliable and way more scalable. So our question has always been, so can we even remove more from you? Can we really remove all this notion of servers from you? And you probably all know the anecdote about pets versus cattle. Servers are like pets. You give them a name. If they get ill, you nurture them back to health. If cattle gets ill, you put them out to pasture and you get yourself a new one. And that basically has always been sort of the premise behind sort of the cloud. You no longer have to nurture things back to health. You can get them in an unlimited fashion for you. But what now if you don't even need to think about cattle anymore? You only think about the herd. You only think about the complete system that you need to build, and no longer need to think about sort of these individual pieces underneath there. So that's where serverless came in. And serverless is something that we've been doing almost from the beginning when we built AWS. Serverless really for us means that you no longer need to do any provisioning for the service that you use. It scales for you. It automatically replicates over multiple availability zones for you. And you never pay for if you don't use it. And we've had many of these different services available for you. Over time, all of these are making up what we call serverless. It's not just compute, it's all the other pieces that actually build this serverless environment for you. And to be honest, for a very long time we've been building these serverless environments for you already, but we didn't make progress on that one last crucial piece. And I think Lambda really brought to life sort of a managed compute environment, where you no longer have to think about sort of managing instances or managing servers or managing just any type of infrastructure. You could just write code and deploy it. And so no more code with the only code, no more infrastructure. You integrate it well with all the different types that you want. You can get full access to identity and access management, and you only have to pay for what you use. And so we see a tremendous change in the way that people are developing their applications. And not just young, let's say, startups or very nerdy environments. No, we see immediately very large enterprises jumping on board as well, because they realize that they can build highly scalable environments and really only have to pay for the kind of compute that they need to do. So if you take, for example, FINRA. FINRA is a government organization that tracks all market data. And so they have these enormous data streams flowing into their services that they've built on AWS, well over 75 billion financial records happening, the financial transactions happening a day. Each of those triggers a Lambda function. Or Vivo, if you're into music videos, then you probably know them. So they build a complete environment where they can ingest data, they can decode code data, they can deploy it to different areas where they actually serve their customers from. They get all sorts of analytics and tracking through that. It's a complete system that they built well within 12 months, and using Lambda. And some of their peak traffic is just outer-worldly, easily 80 times peak traffic if a new song comes out or different times of the day. So they have massive peaks and no longer need to do any provisioning for that. Lambda does this for you. So, or Thomson Reuters, which has built a real-time analytics engine with all data coming in and immediately processing this data and in real time updating them. So well over 4,000 requests a second. So they no longer need to worry about, do I manage a complete EC2 fleet for that? The only thing you have to do is write your Lambda functions and you get instantaneous scalability out of it. Now, if you write one Lambda function, that's easy. But most of our systems are more complex than just having one Lambda function. You have many functions that actually need to work together. And so how do you coordinate between these functions if you build your applications? How do you keep state? And most importantly, how do you handle failure conditions? What if some function fails? Because either you made a mistake in the code, or maybe you can't get access to a resource. How do you do error handling there? And how do you keep all of this in sync and know exactly what kind of things executed and what didn't do? So how do you do auditing of all of this? So with that, we've given you a great environment to build this in. It's called AWS Step Functions. Yeah, and in Step Functions, you can take sort of prototypical application sort of approaches and visually design them in terms of where your Lambda functions are, and then execute those for you. Yeah, so whether those are sequential steps, or whether you want to execute things in parallel, or whether you maybe have sort of a branching, an if-then-else situation. You can design these visually, and then execute this for you. Yeah, so that really helps you with building distributed applications. What also helps you with building distributed applications is getting deeper insight into them. And so in my keynote at reInvent, we announced AWS X-Ray that allows you to keep very detailed insight into execution of all the components that you have. Yeah, and today, X-Ray is available for all of you to use. Yeah, generally available for most of the components. Lambda is just still available in preview, but will be generally available pretty soon as well. So with that, you can get very detailed insight into the execution of each of those, really figuring out which of your components may actually have sort of bottlenecks to drive the performance of the overall system. A key component in serverless is also the database. We need to store data somewhere. It's crucial. Without data, most of our computation doesn't really make sense. And DynamoDB really has become sort of the default database for you to use if you're building serverless applications. Yeah, because it exhibits all the principles of serverless. It is highly available, gives you consistent performance, is highly reliable, automatically replicates over multiple availability zones, and it is just proven scale. You just know how it scales. It gives you consistent performance because you asked for it. Actually, today, you can actually use DynamoDB from inside your VPCs by using VPC endpoints. Yeah? So you no longer need to make a decision to make this traffic to DynamoDB go over the public internet. You can actually use that from inside your VPC. It's pretty cool. Many customers, again, making use of DynamoDB as the crucial building block underneath all the applications that they're building. Yeah, whether that is Airbnb or Expedia, all of them, or take Supercell. I think Supercell is a great example of a company that requires tremendous scale instantly. Yeah, when Supercell launches a new game, millions and millions of customers immediately jump on that game, and they need to make sure that the environment scales to the max at that moment. What we've seen, however, with many of our customers, that are quite a few number of our customers that are actually using DynamoDB, that there is a tremendous shift happening in sort of expectations around sort of how fast things need to go. If you think about sort of ad serving, or if you think about algorithmic trading, or if you think about gaming, many of them where these very fast single millisecond response times is amazing that Dynamo gives you, but their requirements are very different. Their requirements is that they actually need to go to microseconds response time out of their database. Currently, there is no database available that will give this for you. And as such, most of our customers need to go to pretty complex settings. They need to build caches, and the horrible thing with caches is that you need to start managing them, you need to scale also for multiple availability zones, and more importantly, you need to make a lot of code changes because these caches will probably have significant different interfaces than the DynamoDB has it themselves. And so, again, this sort of complicates the life for customers that need to go to a microsecond environment in terms of response times. We've solved this for you. Yeah? With Amazon DynamoDB Accelerator, which is launching today, you will be able to get access, microsecond access to data that lives in Dynamo. DAX gives you the ability to launch an in-memory cache in front of DynamoDB with one click of a button from the console, and actually has the identical interface that DynamoDB has. So you no longer need to rewrite your applications to be able to actually access your cache. Yeah? It gives you microseconds response times, millions of requests in parallel, and of course, as always, to make it simple for you, it is a fully managed environment that actually is highly available over multiple AZs, and so you no longer have to worry about managing your caches and get access to microsecond response time. Now, while DynamoDB is sort of the default application for many of the serverless applications, there's still quite a few of you that are actually running traditional relational databases. Yeah? And with that, I think we've helped you take flight. Yeah? Flight has always been sort of this amazing superpower where you could really remove yourself from the old world. The ability to fly, I think, is something that really sort of speaks to our imagination. And I think as builders, we really like this freedom. Yeah? But these old world databases, they're a nightmare. Yeah, really on-premise or in the cloud, they're very expensive. Yeah, they're proprietary, you get all this lock-in, and especially around licensing, these are prohibitive. And we've seen companies doubling the cost of their licensing if you even want to run your database in the cloud. Yeah? How is this for customer friendliness or customer centricity? Yeah, and we all have seen, if you're running these sort of proprietary databases, this email that says, we would like to audit your license usage. It's a nightmare. Yeah, and I've been on the receiving end of that. We've built, and so I always know that sort of the only way to drive costs down in this world is to make these very long-term contracts. And then as a CIO or as a CTO in this case, you had to sort of estimate what your usage would be 5 years from now. And that would actually target against. And I now know from talking to many CIOs as our customers that they did exactly the same thing as I did. I just overscaled way too much. Many of our CEOs that I know buy 30% more licenses than that they really need, because it's very hard to predict the future. So with all of this, what we see, many of our customers really want to move from these proprietary databases over to open source databases. Yeah, whether it's MySQL or Postgres or MariaDB, for them, that's really important because that's sort of the target, the world that they would like to live in, yeah, where they can see very fast development happening, but in an open world. So we wanted to help our customers there. So we built the migration service, the database migration service, that has by now migrated 23,000 databases from on-premise into the cloud. Yeah, it is a fully managed environment for you, where you continuously sort of migrate data into the cloud while you can have your applications continuously running. You don't need to sort of stop for a whole weekend, stop your business for a weekend because you want to migrate the database. You can do this in real time. And we do automatic schema conversion as well, and I think we just added a number of new sort of data warehouse databases to this as well. Many of you actually were asking us, oh, wait, we like this open source approach, but what we liked about the old world was actually sort of this enterprise-grade scaling or enterprise-grade performance, which is hard to get over the open source databases. Yeah? Which is why we developed for you Amazon Aurora. Yeah? It's sort of the enterprise-grade database, yeah, at a fraction of the cost of the proprietary databases, but actually has high availability that I think even for enterprise databases is unparalleled. Yeah? 6x replication over 3 availability zones means that you always have access to local storage, to local access to your database. It's very, very fast. Yeah? And again, this is at a fraction of the cost, while actually 10x the performance of many of the open source databases. We added for Postgres for you, because the original Aurora had a MySQL interface. But many of you were interested in actually Postgres as a target for Aurora, because they're so semantically similar. to many of the enterprise databases that are out there, the proprietary databases. It's much easier for you to migrate, let's say, from an Oracle database over to Postgres, because semantically, they're pretty close. And so we announced at reInvent last year, PostgreSQL, compatible edition for Aurora. And I'm very happy to announce that this is now available for all of you to use in open preview. So go ahead and start playing with Postgres Aurora. It allows you to actually build high scalable, high reliable databases, let's say, at a still open source cost. Pretty strong usage of Aurora across the board. And probably there's no better example there than Expedia. You know, Expedia runs about 150 travel sites around the world, and they do 300 million writes a day into Aurora, with peaks up to 17,000 writes a second, all at a steady performance of 30 milliseconds. Yeah? And actually, they do many more reads a second for that, really capping that at 17 milliseconds. Yeah? And so this is a high-scale environment that really even the largest operations in the world can actually base their applications on. So with all these databases, there's more things that you want to do with data than just store the data. And especially, you want to get deeper insight into the data that you have. And X-ray vision as a power will give you access to the best analytics tools to actually dive deep into the world of analytics. And so if we take a look at sort of the different areas where we have analytics services for you, on one hand, of course, we have Amazon Athena that allows you to operate against sort of petabyte scale data stores that live in Amazon S3 and where you can just have interactive queries running against that. You only need to pay for what you've used. This is pretty simple. If you can write a SQL query, you can make use of Amazon Athena. Some of you want to build highly targeted, very specialized analytics codes yourself. And you might be using Hadoop or Spark or Presto to do this. And for you, the target environment will be Amazon EMR. And you can build your custom code analytics and run them on thousands of nodes if that's what you would want to do, where we manage this whole execution for you. Then, of course, there's Redshift. Redshift is a true data warehouse service. That's a very different beast than these other two, which are way more targeted towards sort of big data, unstructured data. Redshift is a traditional data warehouse, meaning that you will pull data from many different data sources into your data warehouse, and then have strong consistency requirements across this. And so what will happen is that you want to make sure that if you have your financial tables about products sold, that it really matches up exactly with the information that you have about your products. So there's strong consistencies between the tables. So that makes these three things rather different from each other and really target different style of analytics. So where EMR allows you, or where Athena allows you to access S3 directly, really run sort of interactive queries. EMR allows you to build fully customized code and really own your applications yourself, your analytics applications. And where Redshift will help you build your data warehouse in a way that you've always done this, by pulling data from multiple sources together with strong consistency requirements and actually need to run really, really fast. At least 20x as fast as at any ad hoc query system that you can think out there. And so we have so many customers that love Redshift. It's been also one of the fastest iterating services out there. Customers love Redshift so much that they give continuous feedback about all the things that we need to do. And if you've been actually following sort of the update sequence of new features and services, you will see that Redshift plays a very important role in this. Our customers that use Redshift are extremely vocal. And us being as customer-centric as we are, we listen very closely and immediately start delivering those. There's one area where customers have asked us for to really make significant changes. And that is in the area of storage for Redshift. So what we see is that quite a few of our customers are interested in creating a data lake in S3. Basically meaning that all the raw data of all the updates that we've been doing to the databases get stored in S3. Yeah, and actually what you may end up with there is petabytes or sometimes exabytes of data that lives in S3, and our customers would really like to run Redshift directly on that data in S3. Yeah, because moving all of that data over to Redshift will be sort of time and cost prohibitive. So we've looked at that, and we're announcing today Redshift Spectrum that allows you to run complex data warehouse queries directly on data in S3. Yes, it's actually a pretty big deal. Yeah, and so what you can see is that Redshift, you can actually extend Redshift queries, point them. If you're using, of course, you have to register your data sources that are living in S3 with the data catalog, with the Glue data catalog. If you do that, you can, inside Redshift, if you build your queries, you can point to external tables that lives in S3, and without any changes, actually run complex data warehouse queries where most of the data lives in S3 and the other data lives in Redshift itself. So often you will keep your dimension tables and you'll keep your fact tables in Redshift itself, maybe stored locally, and then access data that lives in S3. So we've done this test for you. Yeah, this is a very complex query against an exabyte of data. An exabyte of data in S3. Yeah? There's a number of tables, and this is a typical sort of what I would call a data warehouse query. Yeah? Multiple joins, grouping by columns, order by numbers of limits and aggregations, all in one query together. If you run this on an exabyte and you use Hive, with a highly sort of targeted build application there, this query will take 5 years to complete if you use 1,000 nodes. Yeah? Complex queries using Hive, 1,000 nodes, 5 years. Can you, by the way, figure out what 5 years of 1,000 nodes will cost you? I think it's fine, but okay. Spectrum, however, yeah, takes 155 seconds to run this complex query on an exabyte of data. Yeah, and it will cost you a few $100 to do this on an exabyte of data. Yeah. This really allows you to build your data lake inside Amazon S3 and run extremely complex data warehouse queries directly on top of this. Yeah, and so when we launched this for the first time, customers immediately flocked to this. Yeah? They really knew what they could actually do with this, and we see enterprises as well as young businesses immediately starting to adopt Spectrum for their really complex data warehousing. Now, there's also an area of analytics that we haven't talked about, that is way more, not necessarily backwards looking, but more forward looking. Yeah, and so if you want to sort of have this view of the future, if you want to have precognition, really know about the future, yeah, there may be different types of analytics that you need to run than your traditional data warehousing. Yeah, and so I've always really tried to push everyone to think about all this data that you already have. Can you use that to build much smarter applications? Yeah, and so, for example, in Amazon Retail, we sit off billions of orders. And we know exactly of those billions of orders, which of those were fraudulent and which were not. So you know you can make use of that knowledge if a new order is coming in to figure out what's the likelihood that this one is also a fraudulent order. Yeah, so prediction about the future is really important. Yeah, you can make use of knowledge from the past to make these predictions, yeah, which all have sort of a score associated with them. Yeah, so there's two kind of tools there that we put in your hands there. On one of it, that is Amazon Machine Learning, yeah, which allows you to take this data from the past that may be living in S3 or in Redshift, yeah, in a visual environment, build your model. Yeah, Amazon ML really helps you in a very simple way. And then immediately, as an output of that, actually get a small service. You get an API point. So now suddenly if I have orders coming in, I just can call this API and actually have that execute my model for you, for me. Yeah, it makes it very simple to develop machine learning applications. And when we launched this internally in Amazon Retail, where we first developed this one, we saw an explosion of the use of machine learning. Yeah? And whether that was this inventory level setting, abusive review detection, counterfeit good detection, all these kind of things where we had already data for, but now we could use the data to make way more smarter decisions. Now, a subset of machine learning that deals with way more complex data sources actually is that of deep learning. And so for quite some time already, we've given you a deep learning AMI. And in this deep learning AMI, there sits all the popular deep learning tools that you use, all the familiar platforms that you have. You know, whether it's MXNet or TensorFlow or Caffe or Theano, Torch, all of them sit in this AMI. And it's either an Ubuntu version or you can use an Amazon Linux version for that. And basically, you can run them immediately and build your own deep learning networks. This has helped, I think if I think about deep learning, why is it so popular? Why is it actually such accelerating? I think there's two reasons for it. Yeah, one of them is really that these platforms like MXNet, where Amazon as well as Apache actually has put their weight behind, is actually allowing you to build these networks much more intelligently and much more customer-friendly. One of the reasons why we actually picked MXNet is because it fits our model so well. Yeah, it fits with us because we give you choice. And with MXNet, you're not just limited to declarative processing like some of the other frameworks, but you can also use imperative programming. Yeah, or you can use all these different programming languages. So it fits really, you have all these choices for you out there. Now, on one hand, there's the platforms that are getting better and more intelligently. On the other hand, there's the hardware acceleration that's happening. Yeah, so the arrival of GPU boards with big memories are actually really allowing us to hold much bigger networks in memory and as such operate much faster. Yeah, so the models that come out of here is you can run them anywhere. If you come out of this, you can run them in the cloud or you can use them in Lambda. And not only in Lambda, let's say anywhere where Lambda runs. You can run it in Greengrass, so it means on your IoT devices, or you can run it, for example, on Snowball Edge. You can bring those models anywhere where you want to execute them. Now, I don't think many of us will be developing this lower-level deep learning algorithms. It's a very unique skill set, and it's basically reinventing the wheel often over and over again if you would have to do that. So I think the real power of all these AI applications with deep learning is coming out of building higher-level services, higher-level applications, or higher-level functions that you can use. And for example, at reInvent, we launched 3 new ones for you that actually really target making it easy for you to integrate these AI services that run on top of deep learning. Yeah, on one hand, there's the ability to actually do recognition, image recognition. So if you use recognition, you can take an image, you can push it through the service, and it will tell you sort of the attributes, the likelihood of the attributes available on this image. Yeah, this is a city, there's downtown, it's urban. All of these kind of things will tell you that. And if you use this for faces, it can tell you a lot about the individuals there. Do they have glasses? Are they smiling? You can think about emotion. All of these is very simple to use, actually. So simple, actually, that one of the architects of C-SPAN that was at reInvent that saw this happening knew exactly what he could do with this. For C-SPAN, it's important for them to, part of their charge is that they have to associate, let's say, quotes with individuals, with politicians, as they are actually saying them. So they have their video streaming in to Amazon. They take snapshots every 6 seconds, and they use recognition to identify the politicians that are on there. Yeah, and they're doing this against an index of 99,000 politicians out there. And so they were able to build all of this whole system, this automatic system of politician recognition, as well as sort of the quotes that came with it, in 3 weeks. No longer having to do all this complex stuff. And actually, they couldn't do the complex stuff before this because they actually were all doing all of this manually. And they saved well over 9,000 hours of manual labor around this. Now, a new feature that you are able to use today, actually, with Amazon Recognition, is that of content moderation. Yeah? And if you show an image like this one, and you are asking recognition to sort of evaluate this, it will come back that this is a suggestive image, a male swimwear or underwear model. And actually, there are 8 or 9 different categories that say the others are more severe than just underwear. Yeah? And so this helps you do content moderation, because quite a few of you will be having an ability to sort of, your customers can upload any image or any data that goes with sort of the systems that you may have built, and you might want to do automatic sort of moderation on this, and we hope that this will help you with that. One of the other tools that we launched is the ability to speak. Polly will help you with that, Amazon Polly. Yeah, basically, if you can feed into this sort of wordings, and Polly will figure out that, no, you should not be saying here the temperature in WA is 75F. Yeah? It will really know that this is Washington and it should be Fahrenheit. Yeah? 47 different languages, 47 different voices, 24 different languages. And so you can also manipulate really what is being said and how it is being said. You basically can add emotion to it. There needs to be a pause here. Or this needs to have some more emphasis. Yeah? And actually, we're adding 2 new features to Polly today. One of them is the ability to have a whispering voice. And the other one is to actually have speech marks. And speech marks allows you to actually sort of, if you have, for example, avatars that have to work together with the speech, actually can operate in sync with it. So let's take a look at this. Yeah, so on one hand, what you see on one hand is the code that is for the voice, where you have the whisper effect in it. And the other one is actually sort of the expression code that you want to make sure that the voice exactly matches up with how the avatar behaves. So let's take a listen to this.
The night was about to fall, and we were still lost in the forest. As she heard branches cracking, Mary started to whisper, "If you make any noise, they will find us. We need to walk silently to the lake."
That was really whispering, wasn't it? Actually, it sounds a lot better if it isn't in such a big hole, but yeah. It is really whispering. So with all of that, so you're able to actually present your customers with a voice interface to your system. And of course, the other part of voice is actually the intake of voice. Automatic speech recognition and natural language processing are key in that. Amazon Lex is the service that we've delivered there for you. Basically, both Lex as well as Polly are the key pieces that also sits in the Alexa service. And so Lex takes in sort of the audio files that are coming in, and will actually sort of analyze that for you and then execute code based on sort of intents which are in the code. Yeah, and then, of course, you can make use of Polly to actually speak back to your customers. And it's really powerful. It allows you to actually do this deep integration with enterprise connectors that are out there already. Yeah, it's a fully managed environment for you, and we'll execute code, for example, Lambda functions for you whenever, so with the particular Lambda functions that you want to have triggered when particular words are being used. Yeah, and so I'm very happy to announce that Amazon Lex is generally available for you to use today, and you can integrate it into any of the applications that you have. And I'm very happy to have a customer that's probably one of the hottest startups around at the moment. Yeah? And as always, we've always think about sort of really high-scale, important startups out there as those that actually have a real consumer offering. Yeah? Slack is, I think, an example, an exception to that, because they focus much more on the B2B space. And they are extremely successful in that. I think all of us, probably in this room, are using Slack in one way or another. And I'm very happy that Julia Grace, the head of infrastructure of Slack, is willing to come and talk to you about how they're using AWS.
Good morning, or good late morning now. I'm Julia Grace. I'm the head of infrastructure engineering at Slack. Slack is a messaging platform for teams, as Werner mentioned. We're the fastest growing enterprise SaaS company in history, with 5 million daily active users and hitting 150 million annual recurring revenue in under 3 years. Now, I was a really big Slack fan before I started working at Slack. I co-founded a startup, and in my capacity as CTO, I was always looking for new ways for my company to work better together. We started using Slack very soon after it came out of public beta, and it completely transformed how we collaborated. I built apps on top of the Slack platform. I integrated Slack with Amazon's SNS, Simple Notification System. And once you go Slack, I couldn't go back. About 4 years ago, I was at a conference, and I ran very serendipitously into Cal Henderson, who is our CTO. I remember grilling him about the back-end infrastructure of Slack. I was really curious how we scaled, how we reached that rapid growth rate and kept up with our customers. Little did I know, 2 years later, I would be the person running that team that maintains and keeps up with our rapid growth. So for millions of people, Slack is the primary communication tool they use all day long. Now, for most other services, think of Facebook, think of Twitter, you're checking it quickly in between meetings, short, ephemeral sessions. But for Slack, our users are using Slack actively, often for 10 hours a day or more. For those 10 hours, they're talking much more than just to other people. And this is much more than just messages, although we do see billions of those a month. The power of Slack comes from when you connect it with other services and tools that you use. So early adopters of Slack were often engineering teams, like I had described my own engineering team. People connected with GitHub, Jenkins. For myself, I connected up with, again, SNS, Zendesk, PagerDuty, our monitoring infrastructure. Suddenly, everything that I needed to understand not only what my team was working on, what we were doing, but everything that was happening with our business was in one place. Now imagine that fire hose of data, 10 hours a day, all of the messages, the notifications, the channels being created, new activity in those channels. Remembering that last unread message, so when you go back to a channel, you can catch up to where you last left off. Saving all of that fire hose of data, fanning it out to clients across the world, remembering those unread messages, managing all that data is incredibly, incredibly complex. Welcome to the world of infrastructure. We also send half of our messages outside the US in different languages across the globe. We're located in every AWS location around the world. Now, AWS is a really critical part of how we have scaled Slack. Our founders previously founded Flickr, which sold to Yahoo, photo sharing site. In that time, they had to buy and rack their own servers. And so they knew when they started Slack that we needed to live, eat, breathe in the cloud. It created a robust foundation for all the things we then decided to do years ahead. So here's an idea of how we use, an overview of how we use AWS. We have a preference for foundational services such as S3, EC2, CloudFront. We make heavy use of VPCs, and we're using I2 and now I3 instances. We run a lot of EMR, Elastic MapReduce clusters, big users of Hive, Spark, and especially Presto. Werner had talked about Athena. We're very, very excited about Athena. It has already allowed us to run complex queries that our current cluster size isn't capable of handling quickly. We're also pretty pumped up about the Athena APIs and integrating those into our analytics workflows. Now, this is a bit about how we've built Slack on AWS. And it's been so awesome to watch how people have then built businesses on top of Slack. With our platform, developers like myself, like before I even joined the company, you can build apps not only for your team, but to reach the millions of users that are currently using Slack. Our ecosystem has over 100,000 active developers. Our app directory launched a little over a year ago and already has 900 apps, and 90% of paid teams use apps. And I'm excited today to announce that AWS has integrated Lex with Slack. Amazon Lex is a set of APIs and an SDK that lets you take advantage of advanced AI and machine learning capabilities. It's powered, as Werner said, on the same deep learning technology as Alexa. Lex has dialogue and tools to allow you to monitor your bots and improve them over time. With Lex, building conversational bots is going to be so much simpler. We are so excited to see what you build. I am excited to build with it. I still build things, really. AWS has really allowed us to do amazing, amazing things at scale. We couldn't be where we are today without them. My team at Slack is incredibly passionate about what we do, and we fundamentally believe that this is the future of work. Thank you so much. Yeah.
Thank you, Julia. Amazing. This is what happens when you build platforms. If you build a platform and you get it in front of customers, then the ecosystem will build by itself as well. And I've always said that the power of AWS is not just, even though amazing, these 90+ services that we deliver, but it's the power of all our partners that are building these things on top of us, like Twilio. Yeah? And that actually allow you sort of to extend, or Stripe, that extend this environment for you. Yeah. And so we have many of these customers that are already using, just like Slack is, these AI systems in production already today. I don't know if you're actually learning languages, but if you're learning languages, then it might be that you're using Duolingo. Duolingo is actually using Poly. Yeah, and if I talk to the CTO of Duolingo, he really says that the quality of Poly is just more than good enough to help customers, to help their customers learn foreign languages. Well, that's pretty amazing. Now, in all of this, we've seen here this morning, I want to conclude, what is the thing that we all want? What is that we're all striving for? Yeah? We all want immortality. Yeah? Not only for ourselves, of course, but definitely also for our businesses. You know, we want to be around for a very long time. And especially AWS and Amazon, you know, we've had this very long-term vision of how to build a business that can be long-term successful. Yeah, where we are continuously, by using all of these superpowers that we've been given, harnessing all the benefits of the cloud, you know, you can try to achieve immortality, being a company that can continuously adapt. What is crucial to immortality is adaptivity. A long life happens only if you are actually adapting to all the new environments. And we allow you to adapt to the new world at speeds that you would never be able to do before. Yeah, and we see, for example, that many of the startups are really breathing life into almost every new industry. Yeah, and that if you're an established business in any of these industries, you better be on your toes. You better start to move fast as well, because when you thought you were immortal, you may no longer be, because these companies have access to exactly the same infrastructure and are moving much faster than you are. Yeah, and take, for example, Airbnb. Yeah, they've had well over 80 million guests in Airbnb since 2008. 2 million homes, 190 countries. Yeah, amazing business. I think any hotel chain would kill for the numbers of Airbnb. Yeah, so all of them are moving really, really fast and upsetting sort of the verticals that they're operating in. For example, Robinhood, really built from scratch on AWS. All of these. Yeah? These companies are able to move so fast because they're no longer shackled to the old systems that are out there. Moving fast, using containers, using serverless computing, making use of all of the services that we have. If you ask any of them, none of them are just using EC2 and storage. They're making use of all the services that AWS has to offer. And that allows them to move really fast. Now, fortunately, of course, many companies out there have realized that, hey, wait, let's make use of cloud computing as well, because we need to actually be able to compete with a whole new group of competitors. Yeah? And we need to change the way that we build our businesses. We need to become digital native companies. And probably there is no better example in this set of traditional companies than GE. Yeah? General Electric is the only company left that was on the originally S&P 500. Yeah? And the reason why that is because they've been able to adapt over time to the changing conditions of business. Yeah? Jeff Immelt, their CEO, had a great quote. He says, one night you go to bed as a manufacturing company, and the next day you wake up as a software and analytics company. And that's really how GE is once again reinventing themselves, building software and building analytics capabilities to improve their own manufacturing processes, to build software to help their customers operate, for example, their massive gas turbines better, or even to actually provide this software to their peers, to other companies. Yeah? They're really now an analytics and software company next to being a manufacturing company. Yeah? So all of these are moving really fast. Yeah? GE has decided to close 30 of the 34 data centers and move over to AWS to achieve this. The same goes for Capital One. Yeah? It's really being able to become a customer-centric, fast-moving company. You need to be able to only focus on what really matters for your customers. So I think to achieve this, there's never been a better time to build. Yeah, if we look at sort of the kind of things that that I talked about today, yeah, whether it's launches like CodeStar or the F1 instances that are becoming available, I think actually that I didn't get an applause for that. I think DAX is absolutely amazing. Yeah? Can I get a calm? Yeah. Microseconds response times out of your database. There is no other database that will give you this. Fully managed, replicated over multiple AZs, available everywhere where you want. This is amazing technology that we're building for you. And you know what? You think it's normal. Yeah? Hey, we announce these amazing things, and you think, oh yeah, of course. Yeah? Let's go use that. Yeah? Yeah, and if you look, do you want to run something for 5 years or for 155 seconds? Your choice. Yeah? And so all of these tools that we make available for you allow you to, there's never been a better time to build. Yeah? So with that, I would say, go build. Have fun. By the way, one thing, there's a fireside chat with AWS CEO Andy Jassy in that side of the room this afternoon, so don't miss that one. And thank you all.